Hello guys, welcome back to this session. Previously we discussed the capacitive proximity sensor. In this session we are going to look at the inductive proximity sensor and inductive switching as a whole. We are going to look at their construction, their wiring and their industrial based application. So let us begin. Now constructively they are available in a wide variety of shape just like capacitive proximity sensor. However, just in the case with the capacitive proximity sensor, the cylindrical inductive proximity sensor is the most common. At the front, right here, in some cases it can be internal, as in the case with this, or it can be a squarish shape. However, usually at the front you will find the sensor's face. Inside is the sensing element which generates the proximity of the sensor. Also on the outer side there is the threads for securing and mounting purposes. At the back end there is the indicator light, LED indicator light, which lights up depending on the detection of the object. And at the very end you will find a cable for IO connections or power signal wiring. There can be a connector of some sort or there can be cable with internal connections. Somewhere along the back end, you will also find a sensitivity adjuster, right? Now it is used for fine tuning the range of the sensor. This acts as a potentiometer, and if you rotate it in a particular direction, its range can be adjusted. In the next slide, we are going to look how these sensors work. Now, this sensor to a layperson, the inductive proximity sensor generates a proximity of some sort. That proximity only affects metallic object. So inductive proximity sensor are particular to metal object detections only, right? Now it turns out that this field is a high frequency magnetic field. What is responsible for creating such field? Now internally there is a inductor coil that is attached to an oscillator circuit, right? And as this oscillator circuit is powered, it generates a reluctance shift or magnetic lines of forces. As the metal target is moved or inside this field, and induced eddy currents are produced in the target itself. Now they generate their own magnetic field which opposes the source, that is the original electromagnetic field of the sensor. This will load the oscillator circuit, and after a certain threshold, which is fine tuned by the sensitivity adjuster, at that certain threshold, this sensor will generate an output signal. So this is the working of an inductive proximity sensor. Wiring, just like the capacitive proximity sensor, they can be a 2 wire, they can be 3 wire, and they can be 4 wire configuration. The 2 wire can be also be a AC voltage source. It can also be a DC voltage source. The 2 wire sensor, it acts as a simple switch, a normally open or a normally closed switch. A normally open switch, right? Initially, when the object is not present, there is no signal output because the switch is open. If the object is present in front of the sensor, right, the normal operation will be actuated and you will get a on signal at the end and the indicator will light up. An NC switch will give a signal, from the start because this is NC, right? And the signal can pass through freely, so from the start it will give a one signal. However, as the object is placed in front of the sensor, it will get open and there will be no signal, right? Now as with the case of 3 wire and 4 wire sensor, there are the NPN configuration and the PNP configuration. In the NPN configuration, from the sensor wire, which from the signal wire, which can be black or white, there will be a negative source, right? So in order to operate a load, you have to connect it with a positive. In case of PNP configuration, the signal wire will carry a positive source, and in order to operate a load, you have to give it negative. You will find that some inductive proximity sensor are covered from start to end, right? Even their sensing phase. Now these type of sensor are shielded inductive sensor, and where the sensing part is exposed, this is an unshielded inductive sensor. So let us see what are their industrial based application. Number one, they can be used for defect detection. As indicated in this diagram, this particular sensor is detecting the broken drill bit, right? It is generating a magnetic field, and if there is no metal part present within that vicinity, it will give a signal and indicate the operator that the drill bit has been broken. Another case, they can be used as a full open or fully closed valve positioning system. For example, at the top, you will find a handle, right? Now, this handle can be manually or automatically operated. In either case, it can be fully open. If it is fully open, this sensor will generate a signal because this check nut will co-align with this sensor. And if this valve is fully closed, this check nut will move down and this sensor will generate a signal that the valve is now fully closed. So fully open, fully closed, and anything in between will be there will be no signal. It can be also used for counting purposes. For example, we saw the inductive proximity sensor in the previous slide with a circular and internal sensing phase. Now, since the magnetic field only affect metal object, so any tubing can be passed through this diameter. It can be plastic, it can be glass, and anything that passes within that sensor will generate a pulse, right? One screw passed, one pulse, another pulse, and these pulses can be used for counting. In other scenarios, the inductive proximity sensor can be used for speed control. Now, encoder is a topic that we are going to discuss in detail in one of the later videos. However, encoder produces pulses within one rotation. So it has something which is known as PPR, pulses per revolution. For example, there can be a encoder with 2500 resolution. What this means that with one rotation, it produces 2500 pulses, right? So these are dedicated equipment for positional feedback of a motor. However, these are also expensive, and what you can do as a cheap alternative is that you connect the motor shaft with a gear assembly or something with a protrusion on one end, and you install or you mount a inductive proximity sensor at the one end. You adjust the sensitivity of the sensor in such a way that get only the teeth get recognized, only the teeth enters the magnetic field. So what I'm trying to say is that within this particular assembly, this one, there are three teeth, right? So there must be three pulses per revolution, right? So this is a system with a 3 ppr, and what we can do with this data is that we can translate it into units of length or into units of time. For example, this motor is connected to a conveyor, and we want to know that how much distance this conveyor covers if the pulses per revolution are, for example, 18. So 3 into 6, it means 6 rotation, 18 pulses will cover a distance of, for example, 3 meter. So this is the basic working of encoder, and don't worry, we are going to cover this in much detail. So the most obvious example for a inductive proximity sensor is presence checking. For example, this is a assembly line for a tin, right? Now this sensor, this detects that whether the tin is present or not, right? And the top one detects that if the lid is present on the tin itself. So if there is any anomaly, any faultiness, so this will be discarded from the assembly line. Also, it can be used for detecting breakages. So much like with the case of counting, you can pass a metal wire through the inductive proximity sensor phase. And if there is a breakage, the pulse signal that it is generated will be broken. And this can be detected that indeed there is no wire in front of the sensor. So these are some of the examples for the inductive proximity sensor that you might find in an industrial based scenario. In the next session, we are going to look at the photoelectric proximity sensor, their working, their principle, and their construction. So see you around then. Thank you.